Good morning, dear students. Today we discuss about the reactions of alkanes. Alkanes shows 7 types of reactions, that are halogenation, combustion, controlled oxidation, isomerization, aromatization, reaction with steam, and pyrolysis. One by one we see the reactions of alkanes. So the first reaction of alkane is halogenation. In halogenation reaction, one or more hydrogen atoms of alkanes are replaced by halogen atom. Halogenation reaction takes place at higher temperature, approximately 300 to 500 degrees centigrade, or halogenation can take place in the presence of diffuse sunlight or ultraviolet light. The reaction which occurs during halogenation is given here. Methane on reaction with chlorine in the presence of ultraviolet light gives methyl chloride and HCl gas. Methyl chloride on reaction with another chlorine in the presence of ultraviolet light gives dimethyl chloride and HCl. Similarly, dimethyl chloride on reaction with chlorine in the presence of ultraviolet light gives chloroform plus HCl gas, and chloroform in the presence of chlorine and under ultraviolet light gives carbon tetrachloride and HCl. The halogenation reaction continues till all the hydrogens are replaced by halogen atoms. So we get mixture of products in this reaction. Synthetically, halogenation is not the useful reaction, because in this reaction we get mixture of halogen derivatives, and the yield of individual halogen derivative is very poor, and therefore this reaction is not so far useful. The reactivity of halogen with the alkane is fluorine are more reactive than chlorine, chlorine are more reactive than bromine, and bromine are more reactive than iodine. So fluorine is highly reactive and iodine is less reactive. So the fluorination is a violent reaction and difficult to control, because the reactivity of fluorine is very high. While the iodination reaction is very slow and it requires oxidizing agent like HiO3 or HNO3 for the reaction to complete. So iodination is very slow and reversible reaction. It can be carried out in the presence of oxidizing agent like HiO3 or HNO3. We can see the reaction of iodination reaction. So methane on reaction with iodine gives a reversible reaction and we get methyl iodide plus HI as a byproduct. This HI should be oxidized in order to get the product by using oxidizing agent HiO3. So we get 3 iodine plus 3 water molecules. If you don't use the oxidizing agent, this HI will again react with methyl iodide and gives the starting material, gives reactants as CH4 plus I2, and therefore it is essential to oxidize this HI byproduct. Now the order of the rate of reaction, rate of replacement of hydrogen, rate of replacement of hydrogen from alkane is tertiary is greater than secondary, which is greater than primary. Tertiary carbon, the tertiary hydrogen is replaced faster, while the primary hydrogen is replaced slower. What is tertiary hydrogen? The hydrogen which is present at tertiary carbon. So here, in this case, this is primary hydrogen, this is primary hydrogen, this is primary hydrogen, and this one is a tertiary hydrogen. The this is primary carbon, this is primary carbon, this is primary carbon, and this one is a tertiary carbon. The hydrogen atom attached to tertiary carbon is a tertiary hydrogen atom. So rate of replacement of this hydrogen is more, while the rate of replacement of primary hydrogen is less. Okay. So halogenation reaction proceeds through 3 steps, that are initiation, propagation and termination. So one by one we see. Mechanism of this halogenation reaction involves, the first step involved in mechanism is initiation reaction. The halogenation reaction proceeds through free radical mechanism. So during first step, the halogen, for example chlorine, undergoes homolytic cleavage and forms chlorine free radical. So this is the first step of halogenation. The second step is propagation. In this step, 2 types of reactions are mainly occur. First one, in this step, the chlorine free radical react with methane and form methyl chloride and the chlorine free radical reacts with methane and form methyl free radical and HCl gas. In the second step, the methyl free radical reacts with another chlorine molecule in the presence of ultraviolet light and form methyl chloride and chlorine free radical. The step of propagation A and B repeated number of times and a chain of reaction is set up. Here the product obtained in step 1 and step 2, step A and step B are principal products, but sometimes other products are also formed in propagation reaction. For example, methyl chloride formed in step B reacts with a chlorine free radical and gives a free radical of chloromethane and HCl. This free radical of chloromethane reacts with another molecule of chlorine and gives CH2Cl2 plus Cl dot. Getting this? Similarly, this byproduct form again react with another free radical of chlorine and forms a free radical which will again react with another molecule of the chlorine and gives a chloroform. So this reaction goes on till all the hydrogens in methane are replaced by halogen atoms. Okay, and the last step in halogenation reaction is termination reaction. The reaction stops after complete consumption of the hydrogen atom in a molecule. Okay, or due to the following reaction. So when two chlorine free radicals combine together, it forms Cl2 and the reaction stops here. Or the two methyl free radicals combine together and form ethane, or methyl free radical and chlorine free radical combine together and form methyl chloride. So these are the reactions due to which the chain of reaction is terminated. The concentration of free radical is decreased and reaction stops. Getting this? Now we move to the second type of reaction, that is, now second reaction is combustion. Alkanes on heating in the presence of air or dioxygen molecule undergoes complete oxidation and gives carbon dioxide and water along with evolution of the heat. So the general reaction is CnH2n plus 2, this is alkane, plus 3n plus 1 upon 2, bracket close, oxygen molecule gives NCO2 plus N plus 1 H2O and liberates the heat. Getting this? Now with example we can see. Suppose a methane on combustion in the presence of dioxygen gives carbon dioxide plus choice of water molecule plus heat. The amount of heat liberated is minus 890 kilojoule per mole. Another example we can see. Suppose methane CH3 CH2 CH2 CH3 plus 13 upon 2 O2 heating gives 4 CO2 plus 5 H2O molecule plus heat. The amount of heat liberated is minus 2875 kilojoule per mole. Getting this? Due to evolution of a large amount of heat, alkanes are used as fuels. During incomplete combustion of alkanes, in the presence of insufficient amount of air or dioxygen, carbon black is formed, which is used in the manufacturing of ink, printer ink, black pigment, or as a filter. The reaction which occurs during incomplete combustion is given here. CH4 plus oxygen incomplete combustion gives carbon black and water molecule. This carbon black is used in the manufacturing of ink, printer ink, black pigment, or used as a filter. Now the next reaction of alkane is controlled oxidation. Alkanes on heating with controlled supply of air or dioxygen at high pressure and in the presence of suitable catalyst gives a variety of oxidation products. For example, 12 CH4 plus O2 in the presence of copper as a catalyst at 523 degree Kelvin temperature and at 100 atmospheric pressure forms methanol Another example, methane plus O2 in the presence of molybdenum oxide on heating gives HCHO plus H2O. This is the methanol. Another example, twice CH3 ethane plus 5 O2 in the presence of manganese diacetate gives acetic acid plus water molecule. Okay.